So in this video, I'll solve UPSC um, physics optional. Okay, 2016 PYQ for IFS. So, if you are a graduate in physics, mathematics, or engineering physics, or any kind of engineering field, then definitely this video is for you. It will very much helpful for you, and in future. Okay, and if you are graduate in BSc or MSc in physics or maths, then definitely you can see it because this video will be very much relatable for you. Or if you are not a graduate in physics, math, or any science related background, then definitely this video is not for you. So um, uh, mane learner, you can give up from here. Okay, so this because this video is not for you. So so that's the main thing. Okay, so first of all, in this video I will write questions one by one, and after that I will solve question one by one. And the problem solving duration time will be in the any kind of optional, like physics optional or any kind of optional. There will be the given time will be around time will be given around 3 hours. Okay, 3 hours. So in the 3 hours you have to solve all whole paper with correctly, and you have to increase your good speed. Okay, so in 3 years I have to solve it, and today I will solve paper 2. This will be paper 2. Whole paper 2 I will solve. Okay, so first section A. So section A is basically given question number 1. So 1A. Okay, so 1A, in nuclear experiment, question is, in nuclear experiment, beams of electrons and protons are moving with velocities, moving with velocities. Okay, c by 10 and c by 20 respectively. Calculate the de Broglie wavelength of both particle in meter. C is the speed of light, where c is equal to 3 into 10 to the power 8 meter per second. Okay, 3 is c is equal to 10 to the power 8 meter per second. So this is the question number 1. Question number 1 is given that there are nuclear experiment, beam of electrons is given here, and I have to solve that the ultimate thing, where c speed of light is given that 3 into 10 to the power 8 meter per second. Okay, so wait a moment. So after that, in nuclear experiment, a beam of electrons and protons are moving with velocity c by 10 and c by 20. Calculated the de Broglie wavelength, where given that, but we know. So in answer, let's say this is answer. Answer will be that's a velocity of proton. Velocity of proton B is equal to 3 into 10 to the power 8 divided by 20. Okay, so is to around 1.5 into 10 to the power 7 meter per second. This is the velocity মানে c by 20 মানে proton here already given that the protons of C by 20 and mass of proton and mass of proton m is equal to 1.67 into 10 to the power minus 27 kg. Okay, and so lambda is equal to, know that h by divided by mv. Okay, where h is 6.6 into 10 to the power minus 34 divided by 1.67 into 10 to the power minus 27 into 1.5 into 10 to the power 7. Okay, so from there you can after calculate it will be around 2.63 into 10 to the power minus 14 meter. Okay, so this will be the velocity of lambda. Okay, so lambda value, when the lambda will be 3 into 2.63 into 10 to the power minus 4. And for velocity of electron, as per question, velocity of electron V is equal to 3 into 10 to the power 8 divided by 10. So it will be around 3 into 10 to the power 7 meter per second. Okay, and lambda will be lambda divided by m dot v. So m dot 6.6 into 10 to the power minus 34 divided by 9.1 into 10 to the power minus 31 into 3 into 10 to the power 7. Okay, 3 into 10 to the power 7. So it will be around 0.24 into 10 to the power minus 10 meter. So is equal to 2.4 into 10 to the power minus 11 meter. So mass of the electron and mass of the proton, I already here you can see it. The de Broglie, when I calculate the de Broglie wavelength of the particle. So de Broglie wavelength of the particle already I am find out here. You can 2 times. So first question is over here. Now second question B. The second question said that recall the Pauli's matrix. Recall the I'll write it in negative column. So second question said that recall the Pauli matrix. Representation of two state. Representation of two state. Like two state of the system. Two state of the system of electron. Basically sigma x, sigma y, sigma z. Okay, and so that they are not commute. So and so that they are not commute. So that they are not commute. So answer will be what here in this question you have to show that that this is not commute. Okay, recall that the matrix representation of the two state of Pauli's system, sigma x, sigma y, sigma z, that this is are not commute. So in Pauli's matrix, so as per the question, the Pauli's matrix are matrices are Sx is equal to h cut by 2 into 0 1 1 0. So diagonal will be 0 and 1, and same xy, it will be around cut by 2 into 0 minus of I 0, and for s z, it will be around h cut divided by 2, it will be 0 1 0 and 0 of minus 1. Okay, This will be the equation 1. And but we work on their until its equivalence. Okay, so first of all I took this is equation 1, and we will work until the both equation will not work. So work until both equation are not equivalent. Okay, so equation are not equivalent. When it will be equivalent, so del x is equal to basically 0 1 0 sorry 1 0, and del of y is will be 0 minus of I 0, and del of z will be 0 1 sorry 1 0 0 minus of 1. So we will be using the matrix language to discuss the spin half particle. For spin half particle, spin half particle, we will use matrix language. So matrix language we will use. Okay, so we note that the following construct what is the following construct that let's say not following construct del of x del of y minus of del of y and del of x, okay, is equal to what will be 0 1 1 0 into 0 of minus I 0, and minus into 0 minus of I 0, and 0 k 1 0, and del of x del of y minus of del of y del of x is equal to 0 1 1 0 0 minus of I 0 minus into 0 minus of I 0, okay, so 0 1 1 0. This will be which is I have to solve it completely, which is sigma of x sigma of y minus sigma y sigma of x is equal to 0 0 minus of I into minus of I 0 0 minus of I. So this will be which is finally which is finally sigma of x sigma of y minus sigma of y sigma of x is equal to 2 of I 0 0 2 of I negative sign. Okay, so it will be around 2 I del k. Okay, and for sigma x sigma y minus of sigma y sigma x, it will be around 2I 0 0 minus of 2I is equal to 2 I sigma z. Okay, sigma z, and for we know that the same again, this is the matrix language. Okay, we know same again what that we know same again what that sigma z sigma x sigma z minus sigma z sigma x is equal to 0 1 and 1 0, okay, into 1 0 0 1 minus 0 and 0 of minus 1, and what was minus 1, and definitely after that 0 1 1 0. Okay, so which is just let's say sigma of x sigma of z minus sigma of z sigma of x is equal to 0 minus of 1 1 0 into minus of 0 1 minus 1 0, which is finally which is finally uh, which is finally what will be sigma x sigma z minus of sigma z sigma of x is equal to 0 of minus 2 to 0 minus of 2 sigma I sigma y. Okay, so summarizing, we have that sigma x sigma y is equal to 2I sigma of z. Similarly, sigma y sigma of z definitely is equal to 2I sigma x. Okay, 2I sigma x. So there are the three components of spin individually are do not commute. So there are three spin are not individually commute. Okay, so this is the individual not commute. So what will be? It will be that sigma of x sigma of y not equal to 0. So this will be the thing. Okay, the question was said that you have to prove that Paulus matrix representation. So for Paulus matrix representation, this is the Paulus matrix representation. Okay, now let's move on question number C. So for question number C, question number C. So for question number C is said that what was the uncertainty principle? What does the uncertainty principle? Okay, what does the uncertainty principle signify? What does the uncertainty principle signify? And consider an electron box and consider an electron box of size 10 to the power minus 10 meter. Okay, what will be its maximum uncertainty momentum? What will be its maximum uncertainty in momentum? Okay, what will be its maximum uncertainty in momentum? So first said that what is the uncertainty principle? तो इससे पहले मैं इसको एक कहानी की तरह सुनाना चाहती हूँ कि अनसर्टेनिटी प्रिंसिपल क्या है. Now, in English, the Heisenberg uncertainty principle is a physical law of a form of a part of momentum of mechanics. It says that more precisely you measured the positions of particle, the less precisely you can you can know its motion of momentum of velocity, and the more precisely you measured the particle of motion, the less precisely you can know that its position. So this is essentially to our everyday experience of life. These measurements are independent of each other, and can be measured as precisely as we did like when it was introduced in 1927. It took a while for people to accept. Okay, so one way Heisenberg tried to explain it to the people was to say that the act of observing something affect of the outcome. Imagine that you are in a laboratory and trying to observe that electrons through that the microscope order and measure that the people positions and velocity. The light imagine that you are trying to observe that the electrons and microscope in order to measure that the positions of velocity. The light that you are using in this observations bounces of electron and reaches in your eyes, and that's how you see. Okay, but the light's effect of electron when it's bounce of it, the light contains the tiny particles called that the photons. Okay, and these particles have that the certain amount of momentum, and this quantity that fast and heavily object have lost. Okay, just like a football player, okay, running has a lot of momentum, which is why it is hard to stop them in case of the light, and amount of the momentum depends on the wavelength of color, okay, and the light, okay, so which can be controlled by laboratory. If the kind of the light we used for our observation has photons which a lot of momentum, and then we can easily see where the electrons is the photons, and it's shining recall brighting into the microscope, okay, because they have a lot of momentum, they will transfer it to the electron when they bounces it and chasing it to speed up, okay. This will make it hard to know that how fast it is affecting, but if the kind of the light we use to photons and hardly any momentum, we cannot easily see where the electrons is, and it's like that the using and microscope in dimmed room, okay, but the sense of the photons have that light of momentum, they wouldn't affect the photons speed and making kind of eraser, and know how fast the moving is the velocity. The better we know the velocity, to harder and it is to know that the positions, and the better we know that the position, so the harder it is to know the velocity. That's uncertainty principle, okay. So that's the uncertainty principle. So if you want to signify that what is the uncertainty principle, so definitely you have to write something like this, okay, with experimental as well as logical and an example also. And what will its maximum uncertainty momentum? So definitely I have to calculate, okay. After that before that, so I'm going to write here again this physical significance of uncertainty principle. uh, mm, so I will write and I will never say anything again. So first of all, I am going to write speed very much speedily, okay. So from here you cannot see my voice. The Heisenberg uncertainty principle is a physical law that forms from part of quantum mechanics, forms from quantum quantum mechanics, okay. Says that the more precisely, it says that the more precisely you measure the position of the particle, you measure the position of the particle, okay, you measure the position of the particle, and the less precisely you can know, yes, you can know uh, মানে uh, its motion and the more precisely you measure the particle, and you can measure the particle, okay, you can measure the particle, okay, particles motion, okay. And on the away of Heisenberg tried to explain on away Heisenberg tried to explain it to people was it to people was to say that the act of observing that the act of observing something affect the outcomes. Something affects outcomes. Okay, something affect the outcomes. Imagine that you are in laboratory. Let's say imagine that you are in a laboratory. Okay, you are in a laboratory and trying to observe an electron, and trying to observe and trying to observe an and trying to observe an electron through a microphone. ঠিক আছে? in order to measure its position, in order to measure its position, through a microscope, through a microscope. Okay, through a microscope. In order to measure to position through microscope and measure of and velocity. Okay, and the measure of velocity. Okay, so the light that you are using in this observation, so the light that are using in the observation basically bounce of the electron, okay, bounce of the electron and reaches your eyes, okay, bounce of the electron reaches your eyes, so that's why you can see it. So that's why you can see it. Okay, that's why you can see it. Okay, and light contains tiny particles called photons. Light contains tiny particles that is called photons. Contains tiny particle that is called photons. That is called photons. Okay, and those particles have a certain amount of momentum. Particle have a certain amount of momentum. Okay, and this is a quantity that fast this is a quantity that fast and heavy object. So this is a quantity that fast and heavy also. Okay, this is a quantity that fast and heavy also. So but so if the kind of the light is use our observations of photons a lot of momentum, then you can easily see where the electron is. But if the kind of light the kind of light if the kind of light we use to as photons, we use as photons with hardly any momentum, with hardly any momentum we cannot easily not easily see where the electron is, easily where the electron is. So cannot see where the electron is, and cannot see where the electron is. Okay. But it's using a microphone in a dim room, but using a microphone in a dim room. Okay, using in a dim room, but since the photons have little momentum, but since the photons have a little momentum. Okay, photons, but they wouldn't affect the electron's speed. They would not affect the electron's speed. Okay, they would not affect the electron speed. They would not affect electrons speed. They would not affect electron speed. Okay, remember that. And making it eraser, and making it eraser is here to know how fast it is moving. First is okay, how fast it is moving. The better we know the velocity and harder to the position, and better we know the position, the harder we know the velocity. So this is the one important line. The better we know the velocity, better we know the velocity, and the harder it is to know the position. The harder it is know the position, harder it is know the position. Okay, and the better we know the position, and better we know the position, the harder is harder it is. Okay, it is harder it is know the velocity, know the harder it is know the velocity. So this is so that's the uncertainty principle. So that's the uncertainty principle. Okay, so that's the uncertainty principle, and this is the ultimate principle of signifying. And after that said that consider an electron box size is 10 to the power minus 10 meter. What will be the its momentum, uncertainty momentum? Let's solve it. According to Heisenberg principle, the product of uncertainty in del x, and that's a uh, let's say professional solving. According to Heisenberg principle. Okay, so Heisenberg principle, uncertainty principle, Heisenberg uncertainty, HUP, Heisenberg uncertainty principle. The product of maintain um, mm, sorry, I'm so writing wrong. The product of uncertainties, in the position del of x and then velocity and del of y, okay, is always equal to greater than, is always equal to greater than, is always equal to the greater than h divided by n pi, okay, pi n, h divided by pi n. So del of x m into del v is equal to h by n pi, okay, is equal to so I'll write here that what is the position is del x and velocity will be represent, so del v. So as per the positions, the question is given that what is the position given, 10 to the power minus 10 meter. So the position will be 10 to the power minus of 10, okay, into m del v is equal to 6.63 into 10 to the power minus of 34 divided by 4 into pi man 3.14 in value, okay. So after that m del v will be 6.63 into 10 to the power minus 34 divided by 4 into 3.14 into 10 to the power minus of 10. After that the result will be 0.53 into 10 to the power minus 24 kg dot meter per second, okay. So after that it will be 0.53 into 10 to the power minus 25 kg dot meter per second, okay. So this will be the thing, 0.53 into 10 to the power 43, and this is the question. And for question number D, so let's write question number D here. Question number D said that consider two electron system. Wait, I will drink little more water. Okay, so the question number question number D said that consider two electron system. Consider two electron system, okay, in ground state, and with orbital quantum number, orbital quantum number 0, orbital quantum number 0 this is the orbital quantum number where it's given that the 0 and L is equal to, let's say, wait, L is equal to 0. Use Pauli's exclusion principle. Pauli's exclusive principle, okay, Pauli's exclusive principle to Obetian to Obetians um, to obedience orientation two electrons, orientations of two electrons. Okay, orientations of two electrons. So what will be its answer? So its answer will be around what its answer will be. So after that, quantum describe that it will be very much lengthy, but I will never create it too much lengthy. The question number is very much 8 marks, so definitely I have to uh, write it. Okay, so quantum numbers of describe the possible state of quantum electrons occupy an atom. So additional rule for that the heliums of second element. Okay, let's say additional rule required to how to electrons is occupied at the available state to explain that the structure of multiple electrons atoms and predict the statement. Okay, for the atoms of ground state has minimum possible of energy and the electrons and distributed over the available state. Okay, so the principle, this principle called the Paul's principle is this type of principle. Okay, so here the question is called system of two particles where that the L is given that already L is equal to 0 of two electron state. So for first electron, so for first electron, so for first electron n is equal to 1 and L is equal to 0 and m is equal to 0. So s is spin half, so it will be half, and for second and for second n is equal to 1, L is equal to 0 and n is equal to also 0 and s is equal to spin up minus of half. Okay, so the second electron in helium atom exists. So the second atom exhaust all possible possibilities, all possibilities. Okay, all possibilities for n is equal to 1, and the anti-parallel orientation of spin is called one state of electron. So I have to write that the anti-parallel orientation of the spin, anti-parallel orientation of the spin of the spin in the first state is a result in the 0. In the first state one s state will be 0. Okay, sorry, b9 will be 0. Okay, first state will be 0, and the magnetic moment which is observed for the helium atom ground state, and magnetic moment for the ground state will be 0. Okay, will be 0. Okay, ground state will be magnetic moment of the ground state will be 0, and providing group of exclusion principle, if the spin of these two electron, if the spin of these two electrons were parallel, this would produce a non-zero magnetic moment. This would produced a non-zero magnetic moment. This will produced a non-zero magnetic moment which has never been observed. never be which is never be observed. Okay, and Paulus observed in an excited helium atom, one electron can be in the first state and the other will be second state. In case, according to the Paulus exclusion principle, the spins of the two electrons can be parallel, which would give the non-magnetic moment and or anti-parallel. Okay, so you can write it or you cannot if you don't write it, but let's say write that the second two lines, that excited in an excited helium atom. Okay, one electron can be in one electron can be in uh, mm, one electron can be in in the first state 1s. Okay, and and the other will be in second state. Okay, other will be in second state. So in this case, according to the Paulus exclusion principle, the two electrons can parallel. Okay, so according to Pauli exclusion principle, exclusive principle, it will be parallel. Okay, it will be parallel. Okay, according to Pauli principle, it will be parallel and parallel. So the spin of two parallel which would give a non-zero magnetic moment or anti-parallel. Okay, in which case the magnetic moment is zero. Both cases have been observed in reality. Okay, and this contribute evidence the exclusive principle, and this will be the exclusive principle. Okay, this will be the exclusive principle. And for the second moment, the question number of E, what will be explain that the Zeeman effect atomic physics. Second question number E is said that, sorry, question number E is that explain the phenomena of Zeeman effect. Explain the phenomena of Zeeman effect. Explain the phenomena of Zeeman effect of atomic physics. Okay, atomic physics. You have to introduce atomic physics for Zeeman effect. Okay, so what will be its answer? So let's say Zeeman effect Zeeman effect basically splitting of a spectral line in by magnetic field. This is called Zeeman effect. Okay, and here explain. So I have to explain it one by one. So writing this, that the Zeeman effect is the splitting of a spectral line by magnetic field, by a magnetic field. Okay, spectral lines by a magnetic field, and that is if an atomic spectral line if an atomic spectral line is 400 nanometer was considered was considered, okay, one considered under normal condition, under normal condition, under normal condition, under normal condition, and in a strong magnetic field, because the Zeeman effect in a strong magnetic field in a strong magnetic field, because the Zeeman effect, because the Zeeman effect, because the Zeeman effect, the spectral lines would be split into wild. The spectral line would be spectral lines would be split to wild, would be split to wild. Okay, so that's the thing. So spectral lines would be wild, and a more more energetic line, and less energetic line, with more and less energetic, and a less energetic line, less energetic line, less energetic lines and more energetic lines. In addition to original lines, in addition to original lines, okay, in addition to original lines, at 400 nanometers, okay, at 400 nanometers, what will be? So the reason for Zeeman effect, so the reason for the Zeeman effect is that in a magnetic field, in a the angular momentum quantum state can undergo, the angular momentum and the quantum state, and the quantum state that undergo, okay, quantum state that undergo a displacement from degeneracy, displacement from degeneracy. For example, let's say example purpose, the p orbital, the p orbital has three possible angular momentum, has three possible angular momentum, okay, three possible angular momentum, three possible angular momentum state that are degenerate, state that are degenerate, okay, that are degenerate under normal circumstance, under the normal circumstance, under the normal circumstance, okay. However, each angular momentum of the quantum state magnetic dipole moment associated with it, okay, and after that, so associated with it, and one magnetic dipole associated with it, okay, and so the separation of quantum state, the separation of quantum state, the separation of quantum state, separation of and quantum state into three different energies, into three three different um, three different energy levels result in three different explosions, result in three different execution. Okay, three different execution. Okay, state with slightly different energies, state with slightly different energies. Okay, slightly with that the different energies that give rise three spectral lines that give rise that uh, that give rise that give rise three different spectral lines. Okay, these are three different spectral lines of slightly differently. Okay, so the original spectral line, one or more magnetic and that are less magnetic upon. So upon this is simply slightly different energies. Okay, energies. Okay, so energies upon the relaxation of atom lines upon the mm, upon relaxation of atom, relaxation of atom. Okay, relaxation of atom. This is the simplest case of Zeeman effect. So this is the simplest case of Zeeman effect. Zeeman. This is the simplest case of Zeeman effect. Okay, Zeeman effect. So normal Zeeman effect consists. So normal Zeeman effect consists. So normal Zeeman effect consists of splitting of spectral lines, spectrum of spectral lines of frequency of frequency f. Okay, of frequency f into three components. Those are frequencies are into three components. Those are what frequency of 1 is basically frequency of pi nu b by 4 pi, sorry, 4m. Okay, and frequency of 1, it is basically frequency of f, and frequency of 3 is also represented that f plus of pi of pb divided by 4m. So this was the question number of pyq question number 1 which I solved. Okay, purely solved. Okay, and it's take time approx 1 hour. So within 1 hour I solve it, and one question. So this is not a good speed. Okay, and I have to solve again 4 questions as per as speed. Okay, so and only 2 hours I have. So that's the main reason. Okay, so this is the question. Now the question number is 4. Question will be come from question number 4, which is the branch of a branch. So 4a, what is the question? Now obtain the frequency, obtain the frequency and frequency nu of r. Okay, of the spectral line of rotation, of the spectral line of rotation, spectral line of rotation. Okay, rotation spectra of the diatomic molecule, spectra of the diatomic molecule. Okay, diatomic molecule, and discuss the characteristic of its spectrum, and discuss the characteristics of its diatomic molecule মানে of its spectrum. Yeah. So this is the question, this is questions, and questions number is very much here asks that the obedience frequency of a new art. Okay. And where frequency of VR. Okay, so new art. Okay, new art is the spectral lines of rotation spectra diatomic molecules. So diatomic molecules के अंदर रोटेशनल स्पेक्ट्रा को मुझे माने फाइंड आउट करना होगा, उसके साथ इसको बहुत अच्छे से सॉल्व करना होगा, और सॉल्व करने के बाद माने आई हैव टू ड्रॉ डायटोमिक माने spectra. So I'm taking a little more break here, and after that I will continue again. So it will take approx 2 to 3 minutes. Okay, so I will come back again to solve it. So I come back again after a little more break. So after that, here you can here the question, as per the question, let's say the answer, what will be the answer? So the answer will be mane the answer sorry. Okay. So the answer, the rotation of diatomic is equivalent rotation of diatomic will be equivalent will be equivalent to a rotation to a rotation, okay, to a rotation of a mass nu, okay, at a distance of r, at a distance of r, okay, nu at a distance of r, let's say this is r, okay, at a distance of r, and then the origin c, then the origin c, the kinetic energy of rotational motion, kinetic energy of rotational motion, মানে kinetic energy, what it will be, kinetic energy will be L square divided by 2L, where L is denoted there the angular momentum, okay, and okay, and angular momentum L omega, where omega is the angular rotational velocity, omega denoted angular rotational velocity. So it is denoted as omega, denoted as what, angular rotational velocity, okay. Angular rotational velocity depended on the omega, which is that the radian per second, this is the unit, radian per second, okay. So the operator of L square, L square is the same of the operator of angular momentum of hydrogen atom, okay. So the solution, the solution of the operator of L square will be basically y of Lm is equal to L into L plus of 1 y of Lm, okay, Lm, where y of Lm basically denoted as the spectral of harmonics, okay. So spectral harmonics, the quantized rotational energy level, so the quantized rotational energy level, okay, energy levels for this diatomic r, basically E of L, E of J is equal to h square divided by 8 pi square